All right, so today we're going to look at distance time graphs. So make sure when you're looking at this, you're looking at the notes that I've put on Google Classroom. You can pause the video at any point in time to copy down the definitions that we'll go over, or to grab something else, and then you can rewatch it as many times as you need. Now, I'm not going to grade your notes. These are just solely for you. So if you want to type them into the Google slide, that's up to you. You'll have access to it at home. Or if you want to print them off and write them in, you can do that. Or if you just want to handwrite everything, that's completely up to you. All right, let's get started. So the first thing we're going to do is we're going to do some definitions. So the first definition we need to look at would be motion. So motion is defined as a change in position. It's measured by distance and time. We have talked about velocity already. Velocity would be your speed and your direction. So 3 meters per second north is one. It gives me both my speed and my direction it's traveling in. You could also say 45 kilometers per hour southwest. You could even say 2 meters per second towards first base. Those are all speeds with directions. It's also really important that if you're a weatherman, you know the velocity. You don't want to just know the direction or the speed of the storm. You want to know both the speed and the direction. Speed is defined as the rate at which an object moves. So we would say it's also distance over time when you're looking at the formula for it. If you're talking about acceleration, now this is a new term. Acceleration is any change in velocity. So if we go back and we look at velocity, velocity is speed and direction. So if I change any part of that, it means I have accelerated. So if I use this example up here, 3 meters per second, if I increase my speed to 4 meters per second north, I have accelerated. If I decrease my speed to 3 meters per second and I'm still going north, I have accelerated. And if I'm going at a constant 3 meters per second, but I change my direction to go east, I have also accelerated because I have changed my velocity. Right, so those are the basic definitions that we've been going over. If you go and you look at the other side of the paper, you're going to need to know these units, okay? So you can cross out this triangle up here. You can look down here where it says time. Time can have seconds. We can have hours. We can have minutes, days, and years. So those are the basic units you'll see this year. Distance, you can have meters, centimeters, millimeters, kilometers, and miles. And then speed, you can have a bunch of different things. So as long as you have a unit for distance over a unit for time, you're fine. So miles per hour, kilometers per hour, centimeters per minute. I could have millimeters per second. That could be one you could write down. All right, now let's get into what a distance time graph is. So the first thing we want to do is we want to define what a distance time graph is. A distance time graph shows how far an object moves in a certain amount of time. I can look at the distance time graph and figure out where the object is going. If it's going towards the start or towards the reference point, or I can figure out the speed from this, okay? Anytime you see a distance time graph or any graph, you're going to want to look at the axis. So time will always be plotted on the x-axis, and I just picked a unit for time, so seconds. Distance will always be plotted on the y. I picked a unit here is meters, okay? The origin for this one is going to be called your reference point. So this is what I'm referring to when I'm looking at something. So it's also called home, like back to the start. Sometimes something will start up here, and so we would say it's starting away from home. Like if I start recording from my GPS when I'm at the grocery store, that's an example of that. Okay, so if you want to grab a ruler and grab a couple of different colors of pens or crayons, then you can pause the video and do that now. I'm going to draw a bunch of different lines on this graph so that you can see. Okay. The first line I'm going to draw is a horizontal line. All right, on this line, it tells me, if I look at this graph, it tells me that where I drew mine, and I drew mine at 5 meters, okay? At 1 second, I'm at 5 meters. At 2, I'm at 5 meters. At 3, I'm at 5 meters. At 4, I'm at 5 meters. So we would assume, or we should know, that I'm staying at 5 meters. So what I'm going to write down where it says a horizontal line means, it means I am not moving. Another way to say that would be it's stopped. Or you could say it is at rest. Okay, so that's a horizontal line. Now the next line we're going to draw, and I'm going to write this down here. A straight line, I'm going to add this in, going up. A straight line going up means, let's draw this on our graph. You can draw it anywhere. I'm just going to draw it right here. Straight line going up. See how it's rising from left to right? So it's going up. The straight line going up means two things. As time increases, my distance increases, which means I'm going away from my reference point. So I'm going to write away from reference point. A straight line also indicates that it's increasing at the same rate, which means that my speed is constant. So constant speed. That does not mean that I am speeding up. It means I'm going the same speed over the whole line. So right here, I'm going 1 meter in 1 second. Here, I went 2 meters in 2 seconds, which is a speed of 1 meter per second. This one, 3 meters in 3 seconds, which again is still 1 meter per second. All right. We are now going to draw a box down at the bottom left. In this box, we are going to say straight line going down. Okay, I'm going to come up to my graph and I'm going to pick a spot, doesn't matter where, and I'm going to draw a straight line going down. This line means two things. Notice, as my time increases, my distance is getting smaller from my reference point. So we would say it is going towards the reference point. And because it is a straight line, again, my speed is constant, okay? My speed is constant. I'm not going to calculate the speed for that line, but just understand, anytime you have a straight line, you have a constant speed. So you set it on cruise control. All right, and now let's look at the last one. So we're going to draw a curved line. And for you, I'm going to draw two curved lines so that you can kind of compare the two. So the first curved line I'm going to draw is going to look like this. So it starts off not really steep, okay? Like if it's stairs, it's not really steep. Then all of a sudden it goes it increases really fast. So this line is saying that I am speeding up. Okay, that's a curved line. That curved line shows me speeding up. Let me draw a different curved line. This curved line is going to start here. Notice on this one, I start really steep and then I just kind of tail off. And this one would indicate slowing down. Okay. So what does the curved line actually mean? It means that I am accelerating. I am either speeding up or I'm slowing down. Okay, either one, and you've got both lines there. Now I want to go back to this line right here. This line does not mean that it's slowing down, okay? It doesn't say anything about my speed decreasing. It doesn't say I'm going backwards either. I'm just going back to the start on the line that's going down. Now, could I be going backwards? Sure. But the chances of me starting at the grocery store and reversing all the way to my house is very slim. I probably wouldn't make it down the street. All right. Now let's look at this graph down here on the bottom. In this graph, I have 3 segments, A, B, and C. So in segment B, I am stopped because that's a horizontal line. If I compare A to C, which one is going faster? Well, look at the lines. This one increases faster than this one does. This is much steeper than this one. So A is actually going the fastest. Okay. If we go over here, it says an object travels 2 meters in 1 second. All right, so this is 2 meters in 1 second. The object stops for 2 seconds. So if it stops, it goes 0 meters in 2 seconds. And then it travels 3 meters in 3 seconds. It says, what is the object's average speed? So average speed is total distance over total time. So how far did this go? Well, it went a total of 3 meters, went 5 meters. How long did it take it to do that? It took 6 seconds if you add all the time. And then you solve and get your answer. And your answer should be 0.8 meters per second. Now you could go over here and tell me what the speed at each interval is. Well, the speed at interval A is 2 meters per second. Speed at B would be 0 meters per second. And C would be 1 meter per second. All right, so that is your notes. Now, I want you to go find that Google slide, and you can do this on the Google slide, or you can print it off, your choice. Okay, I'm going to go over with you how to do it and just look at a couple of different things. So I'm talking about this other worksheet. All right, so if I am looking at this, we'll do 2 or 3 of these together. This one says distance from the reference point. So at 10 seconds, where's the line at 10 seconds? It's here. How far has it gone in 10 seconds? How far away from my reference point is it? It's 10 meters away from my reference point. Okay, and this line is going up. So is it moving away or towards the reference point? If it's moving up from left to right, it's moving away. Is it moving fast or slow or no motion? Well, this would be moving fast if we compared it to other ones. Okay. If we look at 30, so right here, 30 seconds, it has moved 20 meters. Because it tells me right here, 20 meters. Okay. Now, is this moving at all? No. So it's none. It's not moving towards, it's not moving away. In fact, there is no motion. Because it tells me at 20 seconds it's at 20, at 30 seconds it's at 20, and at 40 seconds it's at 20. So it's staying still. Let's look at C, and then I'll let you do, or 50, and then I'll let you do 85 by yourself. So at 50 seconds, which would be right here, how far away am I from my starting point? Well, I'm around 16 or 17. We'll say 16 meters. Is this line moving away or towards? Well, it's decreasing the distance, so it would be towards the reference point. Okay, this line, if I compare it to A, is actually a little bit slower. Okay, now I want you to finish this one. Now, let's go down here and look at a couple of these just so you understand what you're doing. You can actually figure out the speed on each interval. And we kind of did it on the last worksheet on your notes. But if I look at time, interval A, which is from here to here, so I'll trace the line. Okay, to do this, I need to figure out the total distance A traveled and the total time it took. Well, it went from 0 to 20. So I'm going to write my work over here, which is 20 meters. How long did it take it to go that far? Well, 0 to 20 seconds is 20 seconds. Do the math, and you get 1 meter per second. Okay, let's look at C. So C is a little different. I start here, change my color. I start here, and I end here. So I'm just looking at that one segment. So I start at 20, I end at 10. You're never going to have a negative distance. You'll only have a positive distance for me. So if I start at 20 and I end at 10, how far did I actually travel? I traveled 10 meters. Okay, that's how far total I went in that segment. How long did it take me to travel those 10 meters? Well, I started at 40 and I end at 70. So that didn't take me 70 seconds to do it. It only took me from 40 to 70, which is 30 seconds. Okay, so you do the math and you end up with 0.3 meters per second. Now in my class, give me decimals, don't give me fractions. Put it in a calculator and solve it. Okay, so that kind of explains this section to you. If you look at section 3, it tells you to do the speed just like you did for each interval, okay? But the last one says that speed from A to D. So from A all the way to D, you do, even though you're stopping and starting, you tell me, okay, well, how far total did it go from here to here? Well, looking at the graph, it tells me it went 60 meters. How long did it take it to go those 60 meters? Well, look here. It took it 100 seconds to do that. 100 seconds. And then you would plug that in your calculator and go. All right. So for the other part that you're going to do, which is this, and I know it's kind of hard to see these, you are basically just describing exactly what's happening in each graph. And you don't have to be as specific as this one is. So like this one, you could say it's moving away from the starting point at a constant speed, or the reference point at a constant speed. And then it slows down in that second interval. Okay? Does everybody understand that? All right. So the next one, you would say it moves away at a constant speed, because remember the line is straight. And then notice I have a horizontal line. Is my distance changing on this horizontal line? Because I'm reading the axis. No, my distance does not change. So I would say that it goes away from the reference point at a constant speed until it stops. And let's just stop it right there. All right, so hopefully you understand what your assignments are. If you have any questions, just message me on Google Classroom.